Hello, hello, hello. Oh, what just happened? Hello. Can I get, okay. You can hear me?
Yes.
Great.
Yeah.
Thank you very much. Okay. So, okay. Oh, thank you. All right. So thank you, Marissa. Thank you, Ardell. Thank you. I think that was Wendy. I'm not sure, but thank you, Ardell. Thank you. Thank you. Oh, not that was it. Thank you, Marissa. That's what I meant. Yes. And for real. Okay, we're gonna step it up today in a way. We're gonna start. I think we're gonna. Things are gonna maybe start happening in a slightly more, maybe joyful or not ponderous way. Here's what. Again, I want to assure everybody, whatever is going on in this class, whatever the deal is, we are not behind anything. You are not behind me. I am maybe behind you. We are not behind anything. We are going to learn everything that we do need to learn, and we are not going to get bad grades and all that. But we also are, or I think I have suffering at the hand of my suffering here, just being miserable with Zoom teaching. But I think we have I'm going to try a new approach today that I think will help a little bit, or it did in the other class anyway. Here's what's going to happen. Oh yeah, you'll see. Hopefully you saw in Google assignment stuff. Two new homeworks that look, excuse me for 1 second, what just happened? Wait, oh, hello? I don't know if that was on my end. Okay. Two things that went to the Google stream and then one got changed. And this is a left turn in terms of homework. Some of you may still feel like you're behind where you're supposed to be. Many of you may feel like I'm behind where I should be with you. That's all true. But what's gonna happen here is I want to start shifting some of the homework points to classroom participation points, I guess, to put them mildly. I want to start giving a lot more points. I want to give a lot more faster rewards for anybody who's actually paying attention or like helping us together here engage while we're in these crazy Zoom times. So we're going to do things more like what used to be called board meetings in lab when we had labs. This is hopefully just going to make it better for everybody. I don't mean to make this harder at all. If you see the board right now, you'll see that there's a question on there, like the question of the day that we're going to start with, which is not much of a departure from yesterday's question. It might be a little harder. It might not. I don't know, whatever. And then that's part of what I never know. So what we're going to do is this. We're going to say, there's the question. I'm not putting anybody in breakout rooms or anything like that. But the question is yellow. I will move on once I get a right answer to that question. I will say as little as I can until I get a right answer. And I don't mean this as a threat either, but like, there's a question. It might be super easy for some of you. Some of you might already have the right answer, like even before I'm done talking, in which case, whichever one of you does whatever is going to say in the public chat or publicly like the answer. And if that person's right, they're totally going to get 50 points, but that's not even the issue. Also the issue is then if that person's right, I might ask them to explain it or I might not, but then we'll move on. But more realistically, let's say, and we'll move on to a harder question. But more realistically, let's say I've asked this question now, you see the question, right? You think you have the answer, but it might be wrong, or you think you have a thing to do, but you think it might be wrong, but you don't, it might be so, or you have a question. I'm going to say, what I'm saying here is once I throw this question to you guys, we're not going to move on until we get the right answer. And I will tell you when we have the right answer, but until that time, until we have the right answer, anybody who says anything at all, like it could be wrong as rain. I mean, not anything offensive, obviously, but like anybody who says anything, even if they admit, if they're like, dude, I can't even, like, actually, I don't even know how to do arithmetic, or like, I never even understood what he meant by distance, or like, you could say anything at all that would sort of help us get to an answer here, or help someone else tell you what to do to get an answer. Anybody who says anything in the public chat or like vocally, right? Say their comment is, I think this is too hard, okay? Like, right? Then what they're gonna do is at some point between now and the next class between Monday, they're just gonna write their name on a piece of paper and be like, I was the one who said, I think this is too hard, which by the way, probably would already remember by then anyway, but they're gonna write that down. They're gonna submit it as the assignment where it says, what I put in your stream where it says like the game take one. Literally all I'm asking is for anybody to make any comment at all today, any comment that anybody makes, once they make, if it's like, when we're in this period of doing this, if they make any comment, it could be totally wrong. It could be a question. It could be a, could you repeat that to someone? But if they say it, then they're just going to write down what they said, just like to remind me. And to be honest, whatever, and they're going to submit that into this assignment portal. And that is 50 points, like a 50-point assignment, like 50 homework points, which is not small. It's like equivalent to a whole homework. They'll get a whole homework like for that, for just doing that. And I'm dead serious. I'm going to go a step further. And that's anybody and everyone, right? Like, so say like I'm talking right now, say, say Ardell already said something. She could say something again. I'm not saying, wait, what am I trying? I'm saying whatever you say, you'll get 50 points for. Then let's say someone actually gets the right answer finally. I'll tell you, oh, we're at the right answer. Great, great, great. All the people that said anything will have all gotten 50 points. Then we're going to move on to the next question. It'll still be true, like wherever we're going, if you say anything, you can get 50 points. But now then the question comes, could you get more than that? Like, are you just going to say like one thing and then like withdraw from the period or whatever? Well, the one thing I'll just add today is that anybody who says anything that is either deemed right, like the right answer, then they can submit it twice. Like they're literally going to submit one thing that just says, here was my contribution for the day. And they're going to submit a piece of paper into the other assignment, the one that says a game right or wrong, for right or wrong. There, if you actually got an answer that I said, that's right, yes, that's it, that's good. Could you explain that? Now we're going to move on. You'll literally get to submit the same contribution twice for an additional 50 points if I actually said that the answer was right. But here's really the flip, is that's also true if I say it's wrong. If you say anything that's even like gutsy enough that it could be right or wrong, because I think that's like the big problem for all of us is like nobody wants to go public with like wrong stuff. And I think the real deeper problem is that people think stuff is wrong that isn't even wrong. Like it's not even embarrassing. It's like so helpful. It's just not complete or something. That I'm saying, you say anything in this class, then you remind me of what you said, that's 50 points. If you say anything that is like actually specific enough that I go, that's right. Or I go, okay, that's actually not right. Like that's wrong. Like, no, it's not 0.2 seconds, but if I say it's right or it's wrong, you get an additional 50 points. Like you get, and I don't mean to get overexcited, but I seriously mean this. You can submit your same comment in 2 different portals for 50 points each. And just remind me what you're doing, you know, just like say, this was my contribution, but you said it was wrong. So I'm submitting it in both places, right? I'm saying I will give literally as many points for a wrong answer as for a right answer, just because I think they both take, because you don't know if you're right or wrong until you hear, so it takes guts either way. And the point is not the right answer, but at the same time, what I'm going to try to do is like not say as little as I can for you guys to just until you get the right answer, and then we'll move on. So like, I guess what I'm at, and this is what I'm going to try to do is not just today, but for today you're currently, sorry. Okay, in 1 second. Okay, let me make one more thing clear, because this is a little bit of a change. What I'm trying to do is take what was always meant as our homework policy grading and shift it into the classroom, because for a number of reasons, not the least of which is that I think Zoom requires something different. But I want to emphasize to everybody, the whole point of this system is that it's a win. It's meant to be a rewards only, no punishment, rewards only system. That is, in the worst case scenario, if we go through this entire class today, and like what happened in the last period, I have to say discussion was a lot better. Like I actually was able to straighten out things for people that they had been confused about for a while, but like no one knew they were confused and blah, blah, blah. Like it was a more productive class, and a bunch of people said things. So a bunch of people got 50 points. Some people didn't say anything. Okay, fine. So all that just means is they didn't get 50 points that day or something, and there will be plenty more opportunities. And if it starts being all the same people, I will change things. But by saying something, I mean you either say something or you put it in the chat. You can totally put it in the public chat, and it will be point worthy. Private chat is very useful and important. In fact, like sometimes I have to break from time to time to use it. I respect, and someone just had a thing, made perfect sense that it was in the private chat, but that's not for getting points. Like that's for dealing with things that are like outside the thing. So again, I'm not, and anybody who after a while, if we do this too much and it gets crazy, and there's people that are really, really paying attention and really, really with it, but really have a problem, like just don't want, to do this way, they'll talk to me personally and we'll work something out. But what I'm trying to get at is I want to interfere less and comment on right answers more. Like I want to just see from you guys how we get through this stuff. And the goal is to advance. That is the goal, to progress, not to reach any level of perfection or anything. I'm going to assume it's sort of clear what any questions about what I'm trying to, so I'm saying, here's the question, Q1, the yellow thing right there on the board. If someone says a right answer, I'll say it's right. And I'll be like, yay, and they'll get 50 points, and then I'll explain it, we'll move on. But until there's a right answer here, I'm saying you guys just talk like amongst yourselves or say whatever you want. And anybody who says anything is going to get 50 points for that. Could you please raise your electronic hands if what I'm saying makes sense? Cool. That's it. Thank you, Ishan. Thank you, Ardell. Thank you, Elizabeth. Thank you. Now, by the way, thank you, Ingrid. And I'm like, awesome. Thank you. Now, by the way, just not to be weird, every single one of you that just put up your hands, like Abby, Kimberly, Sheeran, Rachel, and I know the other, both Rachels, I'm going to say right now, I hope all of you do like actually say something about this physics, but since you do get it, literally at the end of this period, if you turn out not to have said anything, you guys, all of you who just raised your hand, can write on the piece of paper, I raised my hand electronically when you asked, is this clear? Like for real, I'm saying that's 50 points right there. Because, and I know it sounds desperate because it kind of is, but because like any bit of information I get from any of you about what's happening mentally is like so helpful to everyone that even when you do that, when you raise your hand, when I say, are you there? It's like super helpful. So that's your 50 points right there if you want it to be, any of you who don't come up with another thing to say. But that said, so now I'm going to feel like it's sort of clear. This is all in friendliness, by the way. It's because I think I've been killing the spirit of this class with like, just like not trying to make it like a regular class. And something has to happen so that the spirit is not killed. So this is about me resurrecting myself, not yelling at any of you. But that said, okay, so Rachel has her hand up. I don't know if Rachel, if your hand's up just because it was before, or you want to say something. If you want to say something, rocket, or maybe she doesn't, or an Ishan. I mean, you guys, if Ishan, if you want to say, if anybody has anything to say about this question, just go for it. You don't even have to raise now, just go and you'll get the point. But the question—
Is there time to hit the ground 1.4 seconds?
Yes, it is, by Cracky, you the man. That saved a lot of, good. Now you just saved all your colleagues from like a 20,000 hour lecture that they don't need. Cool. Could you just briefly explain that? You're totally right. And please write that tonight. So you just got, just to be clear to everybody, and I'm not trying to blow smoke up anybody's direction, but he just literally, what he's going to do is he's going to write down that he said 1.41 seconds to the first question. He's going to write it and submit it twice. One to the general portal for just having said anything, and one to the portal that's called like for right or for wrong, because I'm saying it's right. But again, he would do this even if I said it was wrong, but he's going to like double dip on this one. I hope he will. And that's how this works. But now, just as a reward, could you please briefly explain to everybody how you just did that?
I'm kind of not sure, but like I like took gravity into account. Like, okay, you're dropping a mass from 10 meters above the Earth's surface. So it, like you specifically pointed out the Earth. So I was like, okay, let me use gravity in this. Okay. And like I did something weird on my iPad and I ended up with that answer.
All right, totally fair. That's great. If I could give you 3 times 50, I would give you 3 for that's hilarious. Okay. And by the way, does anybody, I don't know if anybody else knows, but I suddenly feel like about 20 times closer to this almost feeling like a human class than I ever did before, just from that. So that's like half my goal. So thanks. Now I know who this guy is, Ishan, who I did it before. Kind of, and okay, his grade, and not to be crude, but does everybody understand that his grade just necessarily got higher in this class for the right reasons, which is just that his like spirit and mind are there to learn. Like, it's just like that. So thank you. So yeah, and he's right. So let me also say now to everybody, and again, I'm just going to overpraise everyone until everybody feels praised. Okay, honestly, to everyone, like no one needs to get an F in this class. No one needs to get a C-, and no one needs to be worried about anything but like not taking advantage of what little opportunity we have to. So this is what I think he did. I mean, so now I'm doing my version. Actually, wait, I'm sorry, even better, before you start copying, here's my version of what he did in his mind. Like, I don't think he literally did every one of these steps in his mind, but what he is, he's definitely using the gravity thing. He's saying, well, the object's falling, so let's use this gravity at constant acceleration that Yaverbaum's been talking about forever. And you could call it 9.8 meters per second squared, or you can call it 10, which I highly recommend. Wait, I want to look in the chat for a second. I'm sorry about that. Oh, great. Great, great, great. Oh, sorry. Oh, yes. Yes, and I'm sorry, and I was slow on this. So like Abby is in the chat now. Can I say also, Abby totally, first of all, she's saving you all the time because yes, what she's saying is a more concise version of what I'm trying to say here in yellow. She's totally right. She should totally double dip tonight before next Monday. Like, thank you, Abby, for participating at all. Thank you for the fact that what you're saying is totally correct. By the way, even though I caught it after what Ishan was saying, it doesn't matter. Notice some of you might think, well, she's saying the same thing he's saying. First of all, she's not. I mean, he said an answer and she said an actual equation. But second, even if it looks like someone's saying the same thing as someone else, I will give them, if I say they're both right, because for 1,000 reasons. Like no one's ever saying the exact same thing anybody else says. And once they say it their way, it means they own it now. And blah, blah, blah. And even at worst, even if they copied someone else vocally, which I don't even know what that means they were listening to somebody else. So it's not cheating. So yeah, totally, Abby should double dip with that. That is great. And what I'm saying about what she did and what what Ashan did is here in yellow, but now I'm going to do it a little bit my way. I'm here also to teach, right? So I'm going to drag out the steps of what they're doing to show you how it works every time. Like, yeah, I thought gravity, I thought y-axis were falling down here. I thought this equation, I also, to the right, you'll notice I made a coordinate system in my mind. I made a conscious decision now, okay, the axis is pointing up and down. Something has to be called positive. Something has to be called negative. I'm going to make down, good. Okay, I see a chat one second. I'm going to call down positive is what I did. And then I started working the equations way before I put in a number. So I didn't even have to worry about whether it's 10 or 9.8 or anything. But hang on one second, something in the chat. Totally, one second. Okay, I love this question. So definitely Marissa definitely should put this in tonight for homework. Like submit this, remind me that she asked this. Now I have to admit, I don't totally know if I totally understand the question. Can the gravity acceleration be given? I am saying yes, what is given for all time now and will be given on an exam. It is definitely true. Hang on. That there's only one, sorry, hold on one second. As far as what knowledge we have in this class or something, we have 7 equations, but we only have one piece of actual knowledge from the actual world so far that is given on exams. This is given, but it's silly. I mean, by the time you get to an exam, you wouldn't even need it as given. This is always true on the surface of the earth. And especially if you think of it as the number 10, you just accidentally end up memorizing it. But it's true that we'll say things like surface of earth or free fall or some words like that in a problem to indicate something's falling near earth. And then, yes, we do expect at this point, the one piece of knowledge in physics is that the connection should be made. Okay, if it's falling near Earth, it will accelerate at this constant rate. Like that is always true near Earth. It will even be given in an exam as this number, but knowing where to use it or when to use it is up to us, which is to say, whenever this is the part that I kind of laughed, but it was laughed in a good way when Ashan said, like, he's like, well, you, meaning Yaverbaum, said Earth, so I thought I'll use the gravity. That's exactly the point. Like, that's exactly why I did say Earth. That's how it works in physics. Because we say surface of Earth, we do sort of expect you guys then say, oh, it's a gravity thing. And gravity is this number. But we even give the number. But we also don't want you to get too bogged down in the number because there's so many different ways of expressing it. It depends on the context. The point isn't the number. You could always look it up. The point is the constancy of it. So I'm not sure if that answers the question, but that question definitely gets 50 points. Does that answer? Is there something more I could say about that, or should I keep going? Well, for the moment, I'll keep going with what. Oh, okay. Let me see. Oh, okay. Thank you. Okay, great. Thank you. I appreciate it. Thank you. Cool. All right. Bobby. So, what am I doing? Oh, right. So, someone's in the waiting room. Okay, so in terms of solving this problem now, I'm doing it the Aishan way, but I'm doing it my way of his way. Like I'm trying to do a way that will work for all problems to help you in all other problems, or to help for problems that we don't know what to do. So I wrote down this new equation that seems to cover us a lot. Y equals 1 half at squared plus v naught t, right? Now, remember, these are all these equations that we have, and I can write it again. They would be given on an exam too, but I can write them again right now, like the 7 of them. But what they are is the 7 equations of one-dimensional kinematics. This is all about motion within an axis, like, because the whole assumption is if we know how stuff works within one axis, then any other axis will work the same way. So even though there might be 3 axes of space in our world, like if we just understand one of them, then we understand each one of them. So this equation I'm writing here at the top, 1 half at squared plus b naught t, is all supposed to be information about the y-axis. I could even remind myself of that. I could make it clearer by putting in subscripts if I want. Maybe I'll start doing that. We do start doing that around this stage in physics, just to remind. It's not new. It's not a new thing, new information or new equations. But I'm just saying, if you're looking at the y-axis, if you're looking at displacement along the y, then the acceleration you're talking about is vertical acceleration, a sub y. The initial velocity you'd be concerned with is initial velocity, v naught sub y, okay? And so then I have this equation. Then I noticed what Aishan did. I think he said that I start from rest. The initial velocity is 0 in the y direction. So I can cross off that whole thing. So now I have y equals 1 half at squared. Right around here's where a lot of people might correctly, and very reasonably start plugging in numbers. And you can get the answer by plugging in numbers right now. You can. But I'm going to recommend to lift it up a little bit, to do an even better way that will serve you in the longer term, especially in physics 204, where the numbers kind of disappear, which they do. I recommend don't plug in the numbers yet. Just look at this algebra, or this equation that we have. This equation that we're staring at is whatever it is. If it's right at all, if it's true at all, it's true like for all time, like for all numbers, because it's algebraic equation. So I have y equals 1 half at squared. I'm looking for t, the time. So I do it like algebra, rearrange that and solve for t. This is the part people don't want to do. This is the part where especially smart people, especially people in the class who already are getting right answers and maybe are a little bit bored by me, which is fair. But like, this is the thing what they'll be like, yeah, that's like annoying. I don't want to do that. I can get the answer my way. But I'm saying actually, if you're already good at getting answers, kind of know what's going on. No, the very fact that if you don't want to do this is very much why you should do it, because it means you're running away from something algebraic. Like, I'm going to rearrange this now for t. I'm going to say, I'm going through all the algebra and I finally say t squared equals 2y over a. Now that statement is true no matter if I accidentally plug in the wrong numbers or if I do computations wrong on my calculator. Like, this statement is right. So if I were on an exam right now, I'm like 90% through this problem and I just got 90% of the points for real, because this is right. And I'm just, all that's left now is to plug in some numbers. But then in case I do a computation wrong or anything, it's only going to affect this last little step. Not that step, this step. Okay, so t equals like the square root, presumably the positive value. I want to know how much time later. This involves the square root of 2y over a. What is a? Well, a is, now this goes back to, I think, Marissa's question. By a, only because of the word earth, like I wouldn't know what a was. It wasn't given except that the word earth was used. So a is g, and g I call approximately 10 meters per second squared. As long as you're not in the lab, whenever you're doing physics, if you're not literally in the lab, if you're not literally dealing with real actual measurements that like funding is on the line, you always round to 10. You don't have to say 9.8. It's unnecessarily exact. 9.8 is. You can always say 10. I always do. I would never take off points for it. Frankly, I wouldn't even in the lab. But so I have that. G is 10. Remember, I'm saying everything pointing down is positive. So now I can plug in these numbers. I get t equals square root of 20 over 10, square root of 2, and I get the answer that Aishan might have gotten in 2 steps because he gets this problem. But maybe if he did all these steps, there might be other problems he could get more to, or whatever, or he might have done all these steps in his head. I don't know. But the answer is square root of 2, approximately 1.41 seconds. That is the answer. Again, anybody who said anything to help me get toward this answer is getting points. We're going to move on to another question in a second. But first, I do want, in the other class, as soon as they saw this answer, someone in the other class did raise a super fair question. And I don't even know if they meant it about exams or life or what, but they asked like what I prefer, or in physics, what's preferred, like 1.41, knowing that I'm chopping off all these digits and it's not really true. It's like not exactly true. Or would they prefer that I write square root of 2 like you do in math classes? Very fair question. And in math class, the answer is you would write square root of 2. And I would also in a math class, but in a physics class, oh wait, sorry, I have a sheet on this one. Sorry. I just want you to see this. Oh, yeah. Yeah. You might please take a note of this or write this down. In physics, it's a good question. Which is preferred, square root of 2 or like 1.41, da, da, da. And the answer is for all time and for exams or homework or whatever, you do want to write 1.41, not square root of 2, even knowing it's not exactly right. In physics, we're not about what's exactly right. We're about what's measurably right. Math, we love math and math loves us and all that, but math is the province of the exact numbers that we can hold in our mind, but we cannot see in space, time, or on measuring sticks. I cannot have digits going on forever without repeat on a meter stick. In physics, what we prefer is numbers that relate to measurements that we could actually imagine, that actually we get from the lab. And therefore, we know they're always approximate. We're always chopping off significant digits in physics and knowing that because that is what you do in science. But we acknowledge it by changing the equal sign to a squiggly. So it is absolutely true. If you get to the final answer of any question on an exam or homework, your final answer should never just be a number. Anyway, it should always be an equation like V equals 22 meters per second or whatever. In physics, we would prefer that you chop off a bunch of digits and write down what's like, we prefer empirical numbers over exact numbers. The exact numbers are in the mind, the empirical numbers are in the lab. This is where physics is different from math. But that does also means you have to chop off significant digits, but on an exam or whatever, like how strict are we about significant digits? Not as strict as the chemists. The rule of thumb is if we give you a problem, it says this here in green on the side, if numbers are involved in the problem at all, and they start disappearing in physics 204, but if there are numbers in the problem at all, then just give your answer to as many significant digits. Like don't use more significant digits than the numbers given in the problem. That's all. Like that's the rough rule of thumb, and that's really all we enforce. You don't have to be really strict about it. Just don't give more significant digits than anything you see anywhere in the problem. And that's it. That's how to express answers. So the answer to this one is 1.41 seconds. That is the answer to Q1. And some people got points, and that's awesome. But we're gonna move on to Q2. I'm gonna warn you that where I'm getting these questions, it sounds like just steps. The other thing about that answer 1.41. Sorry. The other thing about this answer 1.41 is just note that the answer, like if you didn't get he got the answer fast, okay? It actually took he got it fast. That doesn't mean that anybody's doing anything wrong if it would take them longer if they didn't get it. But it is possible that some other people got a different answer, like 1. Like, even though it seems like I keep asking similar questions over and over day after day, it seems that way, but in a way it's not. We are actually progressing through a counterintuitive concept here, and the concept is acceleration. I mean, remember, I'm saying something fell from rest, and it accelerates at a rate of 10 meters per second every second. I'm asking, how much time did it take to fall 10 meters? It's very natural and very reasonable for people to think, well, 1 second. I mean, didn't you say it's falling at 10 meters per second squared? So, okay, it takes 1 second to fall 10 meters, right? And like what we're really trying to say is, no, it doesn't. It seems like it would, but it doesn't take 1 second, right? I mean, in 1 second, it's only traveled 5 meters, if you look back what we've been saying yesterday. So this is just a reminder of that. But also I'm asking this because this is part 1 of what lab 4 and lab 3 are all about. I'm going to ask you this next question now. I'm going to shut up. I really am. I'm going to turn it to you with this next question. You might find it hard, you might find it easy, whatever, but where you might want to, and you don't need any extra knowledge to answer it, but where you might want to direct your thinking as to anything you remember thinking about in lab 3 or particularly lab 4. So here's the question. Oops, sorry. The question is, oh yeah, okay, here's question 2. We now take a similar situation, another object, a mass that's 10 meters above the ground, but this time we throw it forward with a purely horizontal initial velocity of 50 meters per second. Okay, this is like lab 4. We throw something forward, entirely forward. We don't throw it up. We don't throw it down. We don't throw it at an angle of any kind. We just throw it forward off a table or off a ledge, off a lab table, off a ledge, off a cliff, off of something, so that it just shoots forward at 50 meters per second. And the ledge is 10 meters high and it's near the surface of the earth. And this time I want to know, how much time does this thing take before it hits the ground, to get to the ground? That's my question, question 2. It may be a tricky question, but it's not a trick question, but I'll take any, so anything on this. So this is the question, and you could draw that. Wow. Yes. Nice. Nice. Okay. First of all, so Devin, definitely, that is awesome and gutsy. And even if the answer might be obvious to him, and if there's others of you who also think that's obvious, maybe this is not a buzzer. You can also say something about it and get points. But totally, first of all, Devin should double dip on that one. He should definitely submit tonight that he made a contribution of any kind, but also that he did say something about which I would say whether it's right or wrong. Now, even if that had been wrong, it'd be gutsy to say something that fast and he would still get, but it is right. And let me tell you, it is the same answer as the first question, but it's not meant to be a trick question, and it's not, and it still is 2 separate questions. It is the same answer. He's right. But for whatever it's worth in the other class, and I'm not making comparisons, but it took them like 20 minutes to get to that of legitimate, honest discussion. So, I mean, that's just to say, Devin, gets something that he should feel good about, and is not not to put anybody else down, but it's not totally obvious. Not everybody sees it right away. But having said all that, Devin, would you mind kind of like explaining, or what's in your mind that you would say that, if you don't mind? Or you can put it in the chat, or you don't have to actually at all, but you're totally right. Yes, that is, yes. Yes, I'll even add, that's very good. Wait a second. Hold on a second. Yes, okay. So, and again, not to overpraise him, but the reward is for everybody. Devin just say that, like, that saves everybody a lot of time, because I don't think I could actually say it far more concisely than that. But that is totally true. Oh, yeah. Oh, okay, cool. Wait, let's do that. Right. So here's the, okay. Now, Erica is great. What Erica, so I agree with what Devin's saying. And what Erica, now we're really getting somewhere. I should really shut up. First of all, Erica and Kimberly should definitely submit what they're saying. Just remind me, just like write down one sentence. I know I'm being redundant, but that's 50 points, definitely. And it really helps the discussion. And it helps me know what to say next for sure. Just notice, and everybody's saying something that's actually important to this, because there is something tricky about this. I am asking 2 different questions. I am saying that the answer is the same to both, but that doesn't mean, right? Like when when everybody's in 2nd grade and they say, what's 2 plus 3? You could say 5. And then like a year later, someone could say, what is 10 divided by 2? And you could say 5. And that's a very different question, right? And the fact that the answer is the same for both either does not at all mean that you didn't advance to another question, or might mean something significant. And in this case, it does. Like we're talking about, just to everybody, there's a reason that that Kimberly and Erica is saying what they're saying. Right. And notice what they're saying in the chat. It starts to show also how if you only look at equations and you don't take the words serious, like all the equations are really from words in the first place. And if you don't stay with the words, then the equations fall apart and don't help anybody. Meaning like they're totally right. There's something going on. Like, there is, like what Erica and Kimberly are talking about. Hold on, I think I have a picture for this. Hold on 1 second. Wait, oh yeah, no, here. Okay. Here, so here's the situation. Like, I try to draw it, and what it is lab 4, honestly. Only I've just made up, instead of whatever numbers you got from the photo gates in lab 4, I'm pretending, let's say from the photo gates you got the number 50. So the horizontal thrust I'm saying is 50, and I'm saying whatever meter stick the height of the lab table is supposedly is given in lab 4 too. I don't know how high your lab table was, but so I'm just saying it's 10 meters, right? So those are the two same givens that you have in the lab. And I'm saying we shoot this thing. So we're now, a minute ago, we were just talking about something dropping 10 meters. Now we're talking about something thrust forward, very much forward, but from a height of 10 meters. And the situation is different now because this new object does have horizontal velocity. It absolutely has initial horizontal velocity. That means at the beginning, it has instantaneous horizontal velocity. It does. I'm trying to go back to the chat. Yeah. Okay. Oh, and everybody who's adding to the chat, anything you put in the chat totally counts for this. And even when people are just like emphasizing what other people are saying, like I love what Wendy, yes, forward velocity, right. But no one's saying anything entirely wrong. And there's a reason that there is confusion about this, and that most people get this wrong at first or whatever. We're actually saying something sort of amazing. Yeah, the object is thrust forward with velocity. Wait, so let me back up. Like when I'm saying we have to care about words, I mean we have to keep straight all these things: instantaneous velocity, average velocity, horizontal velocity, vertical velocity, acceleration, horizontal acceleration. Like we really need to keep them straight in a way that goes before the equations, right? And I'm not saying anybody isn't, but even looking at this chat, what's going on in this problem? We've got something that does have initial, instantaneous, horizontal velocity. It does. And as this thing continues to move, it will continue, as it like shoots off the desk in the way that I'm vaguely trying to draw here, it will continue to have horizontal velocity at every instant. It will. Therefore, on average, it will even have horizontal velocity. It will totally have horizontal velocity of any kind you could think of: instantaneous, initial, average. It will maintain horizontal velocity the whole time it's going. And it will be moving horizontally. So it's a problem that deals with horizontality. In fact, so much so that, as you know, in the lab, we can ultimately ask, how far horizontally is it going to get? All of that is happening. But the acceleration of this object horizontally is nothing, is zero. It is velocitizing horizontally. It is moving horizontally, but it is not speeding up, or we have no reason to believe that it is speeding up or slowing down or anything horizontally or changing its direction horizontally. So this is the Devin part now. Like what's interesting is, in other words, Devin's answer that he gave really fast to this question, he's saying it's the same answer as question 1. And he said it really fast. So he didn't do arguably, he either didn't do a ton of work or he just did the same work as in question 1. And then it's declaring that it applies. And he's right. You might think, wait, he forgot. In question 1, the thing is only moving down. And here the thing is also moving over. Devin forgot that it's also moving over. No, what Devin's saying is, I'm not forgetting that it's moving over. I'm deliberately not being distracted by that. I'm saying Devin, and saying it's moving over, but it's not accelerating over. It's moving forward. It has some velocity, but it doesn't have any reason to have acceleration. It doesn't have a change of velocity. Only in the downward direction does it. Okay, I'm going to pause for a second because Ardell, question, point, please go.
Yeah, so is it okay to make the general statement that because it's still dropping from the same height, and you're like ignoring anything else that's acting on the mass, that since it's only gravity, it's going to take the same amount of time anyway?
Yes, exactly. And that is That is the point. That's 50,000 million points right there. Like definitely submit that, even though I already knew but yes, yes, and yes. And that's what I'm saying to everybody. And it's so good that she just said that, because look.
Wait, can you please repeat that one more time? 'Cause
Yeah, I am
couldn't hear
actually.
it. I'm
Do you want
sorry.
oh, sorry. No, I am. Did you mean Ardell to repeat it or me to repeat it?
Whichever feels more comfortable. I just couldn't hear it. I'm so sorry.
Okay. Um, yeah, absolutely. I'm definitely about to repeat it my way, but actually, do you mind, Ardell? Do you want to say your way one more time before I do?
Yeah, I
'Cause
don't
you're
mind.
right.
Okay. So I'm saying that because the mass is being dropped from the same height, and we're not saying that anything else is acting on it but gravity, it's going to take the same amount of time for the mass to hit the ground, regardless of the initial velocity. If it's only horizontal initial velocity.
Perfect. Oh my God. I was actually
Thank
even
you
more.
so much. I
Oh yeah, thank
understood
you.
that perfectly fine.
Huh. Okay, I feel like I could retire right now. I mean, not because I did anything, but no, this was suddenly, this almost feels like a class now. First of all, can I just really point out that Ingrid literally just said, can you repeat that? And that is worth its weight in gold. Like, she definitely gets 50 points for that. Not only because like it showed she was paying attention and yada, 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 and for emphasis, but also, can I say to everybody, I almost didn't want to ask Ardell to say it again because it almost seems like a punishment for saying something in the first place. But when she said it the second time, she said it even more exactly right, like even better. It's exactly right. And it is the point. It is the point of Lab 4. And it's actually a surprise. It is a point, because actually nobody would think this. No, I can't say nobody, but most of us would not actively believe this without or before or entering into a physics class. It's not supposed to be obvious. It just ends up being super important and fundamental, but it's really not obvious. So I'm going to repeat it now my way too. What Ardell is saying, and what Devin is clearly saying, and now what Ingrid is saying, what is true is what's really true in the textbook world of physics, and also in the real actual world of physics. If I go to the pitcher's mound, okay, already that's a fantasy, obviously, but like if I'm standing in the middle of a baseball diamond with a baseball in one hand and a baseball in the other, okay, and I stand there with both baseballs at the same height, this is what I'm saying to everybody. This is the pure version of what like Ardell is. And I love the fact, and she was like, wait, is this really what you're, because clearly there's something weird about it. That's why she wanted to check, and I'm so glad she did. Like if I stand with two baseballs like this, and at the same height, and someone goes, go, like, they stop their stopwatch or whatever. And at that moment, one of them I just release gently, and the other I wing I throw with all my might, but as Ardell qualified, if I throw it at all my might horizontally, like not up, not down, not even at an angle, because that will have some up and down-ish in it if I throw an angle. And she totally qualified that on the second time. She said, like, she totally made it clear that she gets that. But assuming that the second ball, I just like throw as freaking hard as I can horizontally. Or if it's not me, like it's a good pitcher who throws like 110 miles an hour or something. Or by the way, John Jay, forget baseballs. Let's say these are bullets, John Jay. Say one of them is a bullet in my hand and the other is a pistol that I fire horizontally, not at an angle, not some badass thing, but just like horizontally. Now, when you say go, one of them drops gently to the floor. The other one is going forward. And for sure, it's going to go super far before it ever hits the ground. Like at some point, it's going to hit the ground, and it will have traveled really, really far horizontally during that time. It will even describe some kind of interesting curve if you want to be, exotic about it. It will have traveled really far in that time. And the other bullet will just like land right where I dropped it. But what I'm saying to everybody that is interesting, I think is interesting, what Ardell is saying, and I think she kind of put together just now, and clear again, like what Devin is saying is, when the first bullet hits the ground, the moment this little bullet that I just dropped hits the ground, that is the very same moment that the other freaking bullet way over there is going to hit the ground. The other bullet will be way over there when the clock runs out, but the clock is going to run out when the clock runs out. It will hit the ground when it falls to the ground, which is the same fall that the other one has to do. It's literally like someone saying to me and my brother, you both have, an hour to live. I mean, I don't really want to get gross, but like you both have an hour before your time on this beautiful island is over. And so me being me, I'm like, okay, well, that's a bummer. I'll sit here. Maybe I'll meditate if I'm like lucky. My brother's like, psh, he's a fireman, off like a shot. He could like take the last hour of his life or whatever he said was, and maybe he goes and he makes $1 million and he helps 1,000 people like cure cancer or something. And he runs all around the island. But when an hour's over, I'm done and he's done. And that's what falling is. One axis that is obeying the laws of physics at the same time, but utterly independently of the other axis. It is exactly what Adele said, that no matter what's going on here, it doesn't affect what's going on here. Both objects would fall at the same, so the object depicted in these pictures would fall at the exact same time as one that's just dropped. And that is actually the underlying premise of Lab 4. What it is just Galileo's principle again, that the laws of physics operate in every coordinate system independently. I'm almost, but then you might ask, well, then wait. Oh, and so again, everything that the people put in the chat, like most of what people said was right. Like there is horizontal velocity, but what there isn't is horizontal acceleration. So this is a depiction. So like at every single moment of this curving arc that the object has, whether it's Lab 4 or in this problem, at every single moment, it's falling forward at the exact same speed as it ever was, but it's falling down at a higher speed than it was a moment ago. So it's gaining speed all the time, but it's only gaining it in the vertical direction. Therefore, it's falling at a steeper and steeper angle every morning. I think I try to, yeah. So in this next page, I'm saying zoom in more on one point at one instant or location of, so I'm trying to, in the white, I'm just on this page, I'm trying to focus in on just one moment of that larger arc journey. Like it might've been like here's the table and here's the floor. If you just pick some random moment in the journey, at that moment, the object has some instantaneous velocity v pointing at an angle, at some angle toward the ground, like over and down. But what does that consist of? Like why? Because at every single moment, it has some horizontal thrust that it was the same amount that it was given right at the beginning. It always has that. V sub x is the same as V sub naught x, like same as it ever was. And it has some vertical velocity, but the vertical velocity, Vy, I'm trying to say here in the triangle, is building and building and building due to the acceleration from gravity. It's just that both, so physics is happening in one dimension and physics is happening in the other dimension at the same time, but independently. In fact, this is what I want everybody to write right now. This is the real lesson of it. Hold on a second. Wait. I'll go back to that in a second. Yes, please write this. This is a 2-page thing. This is like the statement. This is another version of Galileo's principle, but this is the statement that really is meant to be underlying Lab 3 and 4. What we're saying is, so it's a finding. I'm saying, and please do write this down. It'll take us, to a lot of places. Or in fact, yes, please write this down. But to be more clear, what we've been doing for weeks and weeks in this class, and what we've been doing is one-dimensional kinematics. We've been analyzing motion in a line. It's been getting, I know, sort of maybe frustrating for some people or boring for others. It seems like we're sort of churning through the same slog. And we are, to some extent that's true, but we're about to move out of that slog finally. The reason we spend so much time in one-dimensional analysis in physics is because of our belief that if you really understand, because the laws all apply in one dimension at a time. So we believe if we really understand what happens in one dimension, then in the three-dimensional arena of real space, it's just like 3 of those one dimensions. As long as it's like believing that if you really understand how to get a side of a Rubik's Cube, then you can get the whole cube. Now, actually with cubes, I don't think that's true, but it is true with physics. So what I'm saying, so we're about in physics to move on to higher dimensions. We're about to move on to motion in the 2 dimensions and 3 dimensions, to motion in a plane and in a cube. We're actually moving on in the topic, which is nice. And you already started doing that in the labs. But the good news is you won't really literally need more equations. We have all of the equations we need for one dimension at a time. We just have to understand how to put the dimensions together. So the finding is this here. This is really what, in principle, you would have learned if you were watching what was going on in Lab 3. And I'll check in with you and see if that actually happened. But the statement is every n-dimensional experiment or phenomenon or problem, so every experiment or phenomenon or problem in physics, okay, so every n-dimensional problem, every problem that consists of more than one dimension, 2, 3, 4, whatever, is in fact n one-dimensional problems or experiments or phenomenons occurring independently and simultaneously. I'm going to say it again. This is the generalized, like the rule, the theorem, the law, the practice, the general words for the discovery that tacitly Ardell and Devin and Ingrid and others were saying. Like when they were like, oh wait, in one way or another in their mind, we're like, oh, I get it. This is just happening and is not affected by that. Like the big way to say that in physics and the power of that is, yeah. Any n-dimensional problem in physics, anything that looks like an n-dimensional problem, like for example, the lab looks like a two-dimensional situation. It looks like you got things going on like this while things are falling down. We're saying in physics, two-dimensional situations happen. We're not saying they don't happen, and we're not going to be unrealistic, but the way we analyze them, the way we solve them, predict them, is we say that something that looks like a two-dimensional situation is really two one-dimensional situations, each happening at the same time. That's why we're seeing them at the same time, but they don't affect each other at all. That's a very big, the more practical way to take this away is we're saying, the point is, if you look at something happening in more than one dimension, like Lab 4 is happening in the horizontal dimension while it happens in the Y dimension, the key insight is to realize that the one and only thing that the different dimensions have in common is time. That whatever amount of time it takes for bleh to occur is the same amount of time as it would take for bleh to occur. But that's the only thing that the different dimensions have in common. They are functioning on their own. Like you can have a gravitational acceleration in one while you have none of it in the other. And it's not a contradiction. They don't interfere with each other or something. Therefore, if any of this makes sense, and it feels like to me, at least it does to like at least 4 people, which is exciting. If this makes sense, then I could go on to the next question, which really was the question of the lab. And it is this, and I'll turn it to you. And you might find this super easy now, or not, I don't know. But it is the question of lab 4. So we're still talking about the same situation. We're given sorry. Right, so this, I believe, this is lab 4. So whether this is a review or help, or I don't know. Actually, let me ask, where are you with lab 4? Have you already turned in? Have you guys turned in post lab, or what is the next thing that's due in lab? Is what I'm trying to ask.
I think we're on lab 3, if I'm not wrong.
Yeah, we're on lab 3.
Oh, wait. First of all, wow. First of all, Sabrina, thank you. Do I say Sabrina or Sabrina?
Sabrina, you're good.
Okay. Okay, so Sabrina, first of all, thank you very much. That is totally 50 points, right? Not to be crude, but that totally was helpful. That, if nothing else, totally showed we were so thank you for that. But second of all, oh, I'm really glad you just said that. I'm glad I asked, because everything we're doing is still right. It may mean that I'm slightly less behind. Like, that's, so you have not started lab 4. You've done the lab, like with the island, with all the directions and the map.
Yes, that is what we're on right now.
Oh, okay, great. Okay, great. Then actually, so to everybody, first of all, the thing that's really helpful, and I actually was wrong. I thought you were up to lab 4, but this makes everything I'm doing now actually better for everybody, because it means this is not too late to help you with reports. Honestly, what I'm saying, the statement that I just wrote in these last 2 pages that I'm flipping on the board right now, just so everybody knows, this is the thing I'm writing in white here, like that every n-dimensional problem is really n one-dimensional problems occurring independently and simultaneously. That is the ultimate thing you're supposed to find out from lab 3. That's what lab 3 is trying to teach. I don't know if it helps you get through lab 3 to know this. I don't know if I'm giving away a punchline, but, or to put it in perspective, but like, well, I guess I have to ask this now. You're working on turning it in, but you all already did lab 3 yet? Like, whatever doing it means, you're working on the reports, right? Or yes, thank you, Erica. Okay, so I'm not giving anything away if I say I think you probably all like the goal of lab 3 is put the directions in order so that you get as far away as possible from the center of the island or the center of the graph paper, whatever. And I hope I'm not giving anything away or confusing anybody if I say you probably found that no matter how you put the directions together, you got to the same place if you did it right. I mean, is that a what do they call it when you ruin the end of a movie? Spoil, like, I don't. So is that right? Did you find that no matter how you put the directions together, you get to the same place in lab 3? Do you know what I'm talking? Yes. Thank you, Ardell. That's another 54. Okay. So I don't want to belabor it and I don't want to get myself sidetracked, but like, if you really think through what that means, or if any of you noticed, like, and thank you, Ardell, for real, but any of you, if you noticed, like when you're playing around with those directions, and you are meant to play with them, it's supposed to be an experiment, even though it's just like directions on a piece of paper. It's dumb, but it is meant to be like a let's play until we see something kind of thing, which is what physics is. Well, when you had those directions in lab 3, I'm sure many of you noticed in one way or another in your mind that, like, oh yeah, if you have a 3 east and you have a 3 west, you put them together, no matter what, you're going to go nowhere, right? You can do 3 east and then 3 west, you end up going nowhere. Or you can go 3 west and then 3 east, you end up going nowhere. So many of you realize at some point you could take a bunch of these things and sort of, they cancel each other out, and you could throw them out because it didn't matter what order you did those in, they're going to be, and then you keep doing like that, and you notice in the end, there's just like some amount, all the norths cancel with a bunch of souths until there's some north left over. And excuse me, a bunch of easts cancel with a bunch of wests until there's like some amount of west left over. Or, and I think in the other case it was south, not north, but whatever it is, like if you sift through those directions up, you start realizing, oh, I see, north can cancel out with south, and south can cancel out with north, and north can like add to north, but north can't cancel with east, and north can't add to east. Like the way those directions work is the north and south just interact with each other just like normal numbers, like up 3, back 2. Oh, that's like +3, -2. So the norths and souths you treat like on a number line, and the numbers just add and subtract commutatively. Like the order doesn't matter, because order doesn't matter when you just add up regular numbers on a number line. And same thing with the easts and wests, but they don't interact with each other. So at the end, where all you end up in lab 3, you end up somewhere, some displacement from the center that totally is independent of order. And what it just is a certain amount of east and or west and a certain amount of south, because in the end of the day, each axis is functioning on its own, but at the same time as the other axis. That's what we're trying to see in lab 3. But one last final way, like we're always saying in physics, like the law of physics all work in one coordinate system at a time. It doesn't matter if your coordinate system is standing in your bedroom or on an airplane going 500 miles an hour. It doesn't matter how fast it's going. It doesn't matter what direction. All the laws just independently work. Like you drop something in an airplane, you're standing in an airplane, you drop something, it falls to your feet. It doesn't fall to the feet of someone on Earth. Like And same thing with each axis, is it's independent world of physics. That's what we're trying to say in lab 3. So now this problem that I'm giving you right here today, this is the first time this happened. Well, it's actually a sneak peek at lab 4. For a rare change of pace, I'm actually helping you in advance understand lab 4. Usually people go into it and are freaked out, and then this helps. So hopefully this will help, that in lab 4, you're going to physically do the situation that we are talking about right here. So I'm going to bring us to the final question of it, because we still have 15 minutes. When we answer this question here, you will have actually figured through lab 4, and that's actually probably going to piss off your lab teacher, maybe. You all have Walters H, right? I mean, this is Professor and Mrs. Walters you have, yes or no?
We have Woo, Professor
You
Woo.
woo. Oh, it's really going to piss him off. Okay. No, he'll be shocked if you come to him and you actually know what's going on. Oh, generally people come to lab and they do stuff and then it gets straightened out afterwards in lectures. I think this time, if you guys are still paying attention with me today, you're going to have a leg up on lab 4 and on writing it, hopefully, and it won't piss him off. He'll just be surprised. But here we go with the punchline of it is, okay, given all this, and again, I'm making up these numbers. That's why I thought this problem I'm making up for you right now, you're going to do in lab 4. You're going to have different numbers, of course. Like the lab table will be a different height. You'll have to figure out what the initial velocity is through photo gates a different way. It'll get a little bit technical. But just imagine the situation, what the situation reduces to here is we throw something off a table, like roll a marble off a table or shoot a bullet off a horizontal surface, a cliff, with initial horizontal speed of 50 meters per second. And what's also known in it, so imagine you know that because you measure it through gates or something. We also imagine we know in advance that the height of this cliff or this ledge or this table is 10 meters. And this is all near the surface of the earth. So the constant acceleration due to gravity in the vertical direction, we believe is like G or 10, call it whatever you want. But what I want to know for this problem, what you will want to know in lab is, given these facts, and again, someone might have already figured this out while I was talking, and that's fine or not, but I want to know a number. I want to know how far this object is going to go, like how far away it's going to land on the floor, how far from the edge of the table will it land? You're going to be asked this in lab 4, but it's totally figure outable. And I'm asking you now, we have like 12 minutes. Again, any comment that anybody makes, including a question or clarification, or I don't understand your drawing, Yaverbaum, or whatever, anything that anybody says about this will get them points. If they haven't gotten points already, they'll just write it down and submit it to homework. Anybody who doesn't get points today, no big deal. We'll figure out another way for you to get points next time. But I am saying, even though we only have 12 minutes, I will as soon as I hear the right answer, I'll say yes and I'll shut it down. But until then, I will try to withdraw. So this is the question. And it can't, people who've already talked could talk if they think they can be helpful, of course. But obviously, if at any moment someone wants to wait, oh, chat, I see the chat, sorry. Oh, wow. I think really good. All right, Ardell would totally get, oh, by the way, technically now, she would technically get another 10 points for that right now, because she just said something that I'm either gonna have to say it's right or wrong. She had the guts to say. So now she's already been racking up points up to like, and I will have to make more portals for her and other people. But I will say, to be honest, I really appreciate how fast she got that answer and that she put it. But no, it's not 35. It's not a right answer yet. So we got to do a little bit more work. But 79.8. So now we're saying 80. Am I correct to do that? Wait, sorry, one second. What are you guys saying? Oh, wow, you guys are fast. All right, so again, kudos and heavenly blessings to Ardell and to Rachel and to Kimberly, who all just put stuff in. Because we're making so much progress here, it's feeling so much more like a class. I will say, I think Kimberly's right, or I think I get the same answer as Kimberly. I think. Same credit to everybody, but maybe since I think actually it's the answer that Kimberly's saying, Kimberly, do you want to give a shot explaining what your reasoning is to the world?
Sure. So I used equation 6 again, which is the x equals 1/2 at squared plus the initial velocity times t. But since we're focusing on everything in the x direction, there's no horizontal acceleration. So you're just going to plug in 0 for that. And then for your initial velocity, you just plug in 50. And then since we found out the time from the other problem, which was like 1.4, you just plug that in as well and then calculate it.
Yes, yes, yes. Yes, 1,000 times yes. I literally can add nothing of value to that. Whoa, except for the written version. I hope. Yeah, no, 100% agree. And I have it written down here somewhere. Yeah. Yeah. Like here it is. And we can even, I'll even add, yeah, I mean, so if anybody wants to copy, and again, and I really feel like we're getting somewhere here because like the other, you know, this is the right answer. So but well, anyway, hold on, but there's still a million ways you can get here, but there's also a million ways you could get the wrong things. Hold on, what was I gonna say? Oh yeah. She's totally right. Everybody's totally right. I feel like everybody's. I really appreciate what everybody, but by the way, everything they're saying is right, and it does hopefully make sense once it makes sense, and hopefully once they say it their way or I say it my way, people could see how it makes sense. But never forget, once everything in physics is like it makes sense once you say it, but it didn't make sense until you do. That's always true for all of us in physics, whatever stage we are. It never makes sense until it makes sense, which means you always have to remember, like 2 minutes ago, something, it wasn't because 2 minutes ago we were retarded, like, or we weren't paying attention. It's because it is that deep and you have to just keep peeling off the layers. So every time you don't get something and then 2 minutes later you do, you have to say to yourself, oh yeah, somehow that worked out. Like I got there and I'll get there next time. But it's not because there was something like missing before. In other words, what I'm saying here is you could still do this 1,000 ways or different equations. You could just keep every single thing we've said today. Everybody could literally just solve with this one equation that we're sort of practicing and moving on from. But this one equation that we got a couple days ago, every single one of these can be solved with it, but you have to be super careful and know what you're doing. You have to know that we're only applying it to one axis at a time. So if now we're talking about the x-axis, like now we're asking, how far does this thing go? Oh, and I'm totally going to get Ardell in 1 second. I'll just say this. But if we're now getting how far this thing is going to go, we need to look at its, we're looking at it horizontally. So we need to look at its horizontal velocity, which turned out to be 50, and its horizontal acceleration. Well, it doesn't have any horizontal acceleration. That's 0. So this whole term can drop out of the equation. It's still correct, but then you sort of, this equation ends up looking like the other one, more like, oh, displacement equals average velocity times time. We want to put in its average horizontal velocity. Its average horizontal velocity is what I'm trying to put in right here. But horizontally, there's no acceleration. So it never changes its velocity. So its instantaneous velocity always is whatever it was at the beginning, 50. So we're literally just saying x equals 50 times time, but we're taking the time from the other problem. And that this is the key to lab 4 and the key, and then I'm going to get Ardell and then I'm going to shut up, or the other way around. Just notice what we're saying is, if you actually have a complicated, like the summary of this, and then again, I'm totally going to get Ardell. Summary is, we have a complicated situation here that we've never seen before yet. This is our first 2-dimensional situation, and you're going to see it, whatever that means, in lab. We're literally talking about something that's fired so that it curves down and fall, like it's called a projectile, and that curve you might know is called a parabola. It's like, it's actually an exotic curve. Like this thing is going to fall to the ground in a curve, not even like the arc of a circle, like a complicated curve, but we're not intimidated by that at all. We're asking, how far is this thing going to go? What we're saying is, oh, well, we're just going to figure out how much time it's taking to fall just by looking. We're just going to analyze it as though it was just a falling object. Like we're going to say the time it takes is the same as if we just dropped it because of Ardell's thing, because in that axis, it did not have any thrust. We're going to take that time and then we're going to say, oh, for that amount of time, it's moving forward at 50 meters per second. So it goes 50 meters every second for 1.41 seconds. So we get like 70 point, whatever. And that's, I totally agree. That's the answer. That's what I forgot who just said. So that's totally what, what Kimberly just explained. And now Ardell, take it. I'm sorry.
I was just, okay, it's just a question because I'm curious. So when I was trying to solve it, I was thinking that the vertical acceleration would be the same as the horizontal acceleration. But now I understand that there's no horizontal acceleration. So what would it look like if there was horizontal acceleration?
Oh, great question. Oh my God, I did not see that coming actually. Yeah. Okay, and there's the fast answer for right now. The longer answer is that's the subject of the next few classes actually, in a way. But the fast answer is, right, if there's acceleration down like 9.8, and if there's also acceleration over, which there could be like from a magnet or something like that, then you'd have a number here and a number there. And what it would, then the object would, if those accelerations were the same, then the object would travel at a straight line. If the accelerations were two numbers but different, then the object's going to travel at a curve. Like, because that is technically what's happening here is we have 9.8 and 0. Even if we had 9.8 and any other number like 9.8 and 4 or 9.8 and 17, if they're different, we get a curve. But if those two accelerations were the same, we would get a straight line motion. I don't know if that's a, but
Yeah.
no, oh, sorry. Okay. Yeah, that's okay.
No, you got it. I got it.
Okay. All right. Great question. Guys, seriously, we're going to go more like this from here on. And again, the more we can do like this, just like actually working these things together in class for points like this, then even the less then less and less explicitly will we worry about stuff at home if we have to. What? Oh, that's a great question too, Melissa. Sorry. Yes, Melissa, great. And I forget if you're, yeah. Yes, acceleration can be negative. In fact, okay, so negative and positive is all up to us as long as we're consistent. Like we always have to make a decision at the beginning of a problem, how we're doing it, and then be consistent. Here, in this problem, I made everything positive because here, everything's going in one direction. Like everything was falling down and everything was moving over. If ever anything turns around and comes back, like the other day when we were throwing things up and then they come down, or if you throw something toward a magnet and it comes back, if ever anything is going to go in more than one direction during the problem, then we have to deal with negative signs. And then generally we would make down negative often, and we would call this 9.8 number negative. So to everybody, it's really important. Every time I write G, I just write the number. Whether you make it negative or positive is a choice, and it's up to the problem. Our whole thing is we only use negative signs when necessary because we don't like them any more than you. They're like annoying, but we use them when we have to distinguish one direction from another. So anytime anything turns around or is going to involve more than one direction somehow, then we're going to call down negative or something negative, and then everything in that direction will be negative. Oh, sorry. Wow. Now we're even getting questions that want to do. Okay, this is a much better.
Can I ask another question?
Yeah.
So if acceleration is less than 1, would that be slowing down?
Oh, that's a great question too. Oh, now we're really getting somewhere. If acceleration is even less than 1 doesn't have to be slowing down. It's it could be a fraction like 1/2. It still wouldn't necessarily be slowing down. But if acceleration is the opposite sign from velocity, then something's slowing down. So in other words, and this was like the other, like in other words, if you give something an upward velocity, if you throw something up, in gravity where its acceleration points down, then it's got positive velocity, but negative acceleration, then it will be slowing down for sure. But also true if something is moving in the negative velocity directions. If something is going to the left, but its acceleration points to the right, like from some huge magnet or something way over there in the right, then there too, it will be slowing down. In other words, I'll put this in the chat just because that's a very concrete thing. When acceleration So negative acceleration doesn't have to mean slowing down. Positive acceleration doesn't have to mean slowing down. And fractional accelerations don't have to mean, but an acceleration whose sign is different so an acceleration that's pointing in a different direction from velocity, that's slowing down. Does that make any?
Yes, got it.
Okay, cool. Okay. So every single one of you people in the class, if you said anything today, just jot down on a piece of paper like what you said, just remind me, submit it, and it's 50 points. I really mean it. But really, I really appreciate it, whether it's points or not. I do feel like if everybody trusts me that it doesn't matter, we will get everywhere we need to get, but we have to get there at the pace that is exactly right for this group. And I haven't been able to know what that pace is, and I'm knowing much better now. So no time has been lost. No grades have been lost. I really appreciate what you guys did today. We'll do it again next Monday. And I'm going to run before I spoil everything. Goodbye.